Hi, this is Mrs. Myers, and today we are going to be learning Lesson 3.5, Parallel Lines and Triangles. So, first of all, there are two theorems in this section. One is called the triangle sum theorem. Actually, the book calls it the triangle angle sum theorem, so it could be called either. And the triangle exterior angles theorem. Both of these can be used in proofs, but also probably more commonly used just to solve some diagrams, like find the missing angle measure. Okay, so the first one is the triangle sum theorem, and basically we've talked about this a little bit already. The three angles of a triangle add up to 180 degrees. So if you take the measure of angle A and you add it to the measure of angle B, and then you add it to the measure of angle C, the three angles will add up to 180. So there's also a postulate in this section. It's called the parallel postulate. Not very commonly used, but sometimes we use it for proofs. And it says that if you have a line and a point that's not on the line, there's only one line that goes through that point parallel to the first line. So in other words, I take a line, let's call it line M, and I have a point that's not on that line. If I say to you, draw a line that contains point P and is parallel to line M, there is only one way you can draw that line. There's only one line that is parallel to M and contains point P. That's what that postulate says. Sometimes we use that to be able to prove certain theorems, and the triangle sum theorem is one that is proved using that postulate, so that's why it's in this section here. Okay. So let's try to apply this triangle sum theorem. If we have this diagram in number 1 here, they give us that this angle is 70 degrees and this one is 30 degrees, and we're trying to find the missing x. So if we know that the three angles of a triangle add up to 180, we could say 70 plus 30 plus x equals 180. When we solve for x, we get 100 plus x equals 180, and so x must be 80. Well, if x is 80, how are we going to get y? Hopefully you recognize that x and y are what kind of angles? Vertical angles, and we know they're congruent. So both of these, x and y, are both 80 degrees. Okay, number 2, a little bit more complicated here. We've got two triangles. We've actually got three triangles. We've got 1, and we've got 2, and we've even got 3. So when you see a diagram, you want to look for any triangles that you can, including overlapping triangles. But let's start with the first one here, because I see that they've given me 2 of the angle measures, just like in problem number 1. 2 of the angle measures are given, so I can easily find the third one. So if this angle is 43, and this one's 59, the three angles of that green triangle add up to 180. 43 plus 59 is 102. So I subtract now, and I get x equals 78. So x is 78 degrees. Well, I know now I can add that. I can put that in right here, 78 degrees. If that's 78 degrees, I need to use my knowledge of general geometry here. What's this forming? X and y form a, hopefully you're thinking, linear pair. And so 78 degrees plus whatever y is should equal 180. So 78 plus y equals 180 because they're a linear pair. So y must be 102. Okay, now we're looking for z. So if this is 102 now, we've got 102 plus 49 plus z equals 180. and this is 151 plus z equals 180, and so z equals 29 degrees. Okay, a couple of definitions here. Exterior angles. In a polygon, the exterior angle is the angle that forms a linear pair with an interior angle when one of the sides of the polygon is extended. So if I have, let's say, a hexagon, and I extend one side, this angle is forming a linear pair with the interior angle right here. So this angle is an exterior angle. So if you have a triangle, same idea, and we could extend it anywhere. Maybe we extend this side. The exterior angle is here. That's an exterior angle too. Okay, so when you have a polygon, if there's 5 sides, there's 5 exterior angles that can be drawn in one direction. And there's actually 5 that can be drawn in the other direction, but only 5 at a time here. Okay? So, the remote interior angles of a triangle. For every exterior angle, this is just with triangles now. We don't talk about remote interior angles so much with other polygons, but with triangles, if we have this exterior angle here, it's forming a linear pair with angle 2, let's say. But then there's these angles 3 and 4. These angles 3 and 4 are called the remote interior angles. Think about these words and what they mean. Interior means inside, so they're inside the triangle. Exterior, of course, means outside, so that's why this exterior angle is on the outside of the triangle. It's an extension outside of the triangle. But 3 and 4 are interior angles. Okay, so we've got 3 interior angles. When we're talking about the exterior angle, angle 1 here, the remote interior angles. Remote means kind of off in the distance by itself, off in the distance. Like when you use your remote control of your TV, it's far away from your TV and you can still make your TV work. So it's set aside off in the distance. So the 3 and 4 are removed from angle 1. They're the remote interior angles. So angle 2 is not considered remote interior. That's the angle that's forming the linear pair. So in this case, angle 3 and angle 4 are the remote interiors angles to angle 1. Okay, so we're going to learn a theorem about that. The measure of each exterior angle of a triangle equals the sum of the measures of its 2 remote interior angles. So look at this diagram. We've got angle 1 is our exterior angle, and 2 and 3 are the remote interior angles. So the triangle exterior angles theorem says that this angle, let's call it 100 degrees, is equal to whatever angle 2 is plus whatever angle 3 is. Which makes sense here because if angle 1 is 100, then its linear pair would be 80, right? And if the 3 angles of a triangle add up to 180, it makes sense that 2 and 3 together would have to be 100. So the remote interior angles equal the exterior angle. So if we look at this number 3 here, the exterior angle is 124 degrees. We have 2 remote interior angles here. Based on this theorem, the measure of the exterior angle, which is 124, equals 59 plus the measure of angle 2. So, the measure of angle 2, subtract 59 from both sides, and the measure of angle 2 is 65 degrees. Okay, you try this one on your phone, and then put the video back on when you're done and check your answer. Okay, so using the exterior angle theorem, we say 119, the exterior angle, equals the sum of the two remote interior angles, so measure angle 2 plus 53 equals 119. Turns out measure angle 2 is 66 degrees. Okay, so there's more practice now down below. I'd like you to try all of these on your own, and then turn the video back on. Pause it now. Do it on your own. I mean it, do it on your own. And then turn it back on and check your answers. Okay, so here's the answers to 5 through 10. I'll give a brief explanation of them. You don't have to do this homework assignment. Number 5, it's just triangle sums, so you add them up, they should be 180. Number 6, same thing, just with decimals. Number 7 is the exterior angles theorem, so angle 1 is equal to the sum of the two remote interior angles. Down here you're looking for the value of x, and they're a little bit more complicated. This one I started with this equation here. This is what I did first. 130 equals 54 plus 4y, because that's the exterior angles theorem. And then I solved for y, and then I was able to find this angle was 76 degrees. Then I used that knowledge to write this equation, which the three angles add up to 180, so you solve for x. Here we just needed one equation for number 9 because there was only one variable. So the three angles add up to 180, and you solve for x. And number 10, I started with the exterior angles theorem, where 141 is the exterior angle, and it equals the sum of the two remote interior angles, so 68 plus x, and I found out x was 73. Once I knew x was 73, I could plug it in to this equation. The three angles of the triangle add up to 180, and I got y is 13. Okay, thank you.